Awesome. Thank you all for coming out today. Hope you're all enjoying the VentureBeat conference so far. I know this is the first year for VentureBeat doing a computer vision track, so it's exciting. My name is Daniel Bruce, and I head up the AI team at Levatas. We're an AI solutions provider based in Palm Beach Gardens, Florida. And we offer a broad range of AI solutions, but really our main focus is computer vision and natural language technologies. So I'm joined on stage today by Matt Denesuk, and he's the SVP of Data Analytics and AI for Royal Caribbean. Royal is one of our enterprise AI partners, so we're really excited to have Matt on stage with us today. And then Dave Milone is also with us. David is the senior product owner who heads up the computer vision program at Royal Caribbean. So today the plan is I'm going to talk a little bit about just some of the common challenges that we see in implementing computer vision solutions. Computer vision is it's not a new technology. It's been around for a long time, but it's picking up a lot of momentum in the recent years. It's a very complex technology, and so like any complex technology, there are challenges in implementing it well. So I'm going to talk through some of the common challenges that we see, and then David and Matt are going to talk through some of the specific ways that Royal Caribbean is using computer vision and AI solutions to drive better, more innovative customer experiences aboard Royal Caribbean ships. Okay, so first of all, actually let me flip through here. Okay, so computer vision is not a new technology. If you've been through some of the sessions here and heard about it, it's been around for a long time. It's been around for decades. The reason why it's getting a lot of hype in recent years is due to the convergence of a number of different trends. So first of all, just the massive availability of image data, and that's coming from mobile devices, Internet of Things, edge devices, drones, planes, vehicles. We're generating image data at a pace that's just unprecedented. Storage technology is allowing us to store and transmit that data at a scale that we haven't seen before. And so a lot of organizations are sitting on a literal gold mine of image data. So combine that with a lot of the advances in computer vision technologies like transfer learning, deep learning, the massive availability of scalable cloud platforms like Amazon and Azure and Google and IBM and what those folks bring to the table. And it's creating an opportunity in this space that's really unprecedented. So it's an exciting time to be in this space, and we're excited to see what organizations like Royal Caribbean are doing. So today, before we get into the specifics of Royal Caribbean's use cases, I wanted to highlight some of the common challenges that we see implementing these types of solutions for our customers. As David and Matt talk about what Royal Caribbean is doing, you're going to see some of these themes come through in real-world situations. So first of all, this is a relatively obvious challenge. This is true for a lot of AI solutions. It's not specific to computer vision. But just because computer vision is a supervised learning approach, most techniques for computer vision these days rely on supervised learning. A key bottleneck in the process is the acquisition and annotation of enough image data to train these models. It's easy to overlook, but these systems are garbage in, garbage out. Even though they're very intelligent, a lot of thought and a lot of work has to be put into acquiring image data and acquiring image data that's very representative of the type of situations that you're training these algorithms to work on. So that's always a significant amount of the work involved in creating an algorithm. It's just acquiring that quality data. Another challenge that we see very often is setting up the end-to-end pipeline that goes into operationalizing these solutions. So even the smartest computer vision algorithm is worthless if it's not able to communicate with systems, and that it encompasses everything from where the images come from, if you're using auxiliary data to improve predictions, and everything down to how that data gets actually pushed out into other third-party systems. A lot of conscious thought has to be put into wiring all of that up. You'll hear as David's talking some specifics of what that looked like in Royal Caribbean's case, but this is a common theme that we run into. Another very common challenge is computer vision, just like many other AI solutions. It is exciting, but it's not perfect. And so enterprises that are implementing computer vision successfully have to develop strategies for dealing with and working around the inaccuracy or the uncertainty in computer vision algorithms. A lot of times that uncertainty is unpredictable just by the nature of it. And so putting the right tools or the right scaffolding in place to work around that is important. One other point to make about this is just the selection of the right problem to focus computer vision on is also very important. So selecting a problem where the latent uncertainty and inaccuracy is not a deal breaker. That's a critical step in managing that successfully. Another challenge that we see very frequently is something called concept drift. And so this happens when algorithms are trained against one set of data, but the real world data starts to morph and sort of drift away from the way that algorithm was trained over time. This can cause very adverse effects and often very unpredictable effects. So it's very important in implementing computer vision solutions. It's very important to put tools in place to detect this concept drift as it's happening. And have a way to address it. Usually, addressing this involves looping in humans, both to detect that concept drift, but also to correct it and help these algorithms start to learn and adapt to the real world, similar to the way that humans would. And we're going to talk about a specific case of this for Royal Caribbean so you can see what that would look like. And then the last thing I'll say here is, what we find is in implementing these types of solutions, oftentimes the critical success component comes from recognizing that computer vision is not a silver bullet. It's exciting, but like a lot of technologies, it's not at a state today where it's able to completely replace humans. There's usually a significant opportunity to improve human experience, to make humans smarter. But a key to success is finding ways for the interface points between humans and AI algorithms to be as frictionless as possible. Because really the magic happens when you're able to pair the intelligence of what humans do best with what AI algorithms and computer vision is able to do uniquely well. And so these 5 challenges are things that we run into very often. And I'm going to ask Matt and David to come up here in a second and talk a little bit about what this looks like for Royal Caribbean. Matt's going to come up first. He's going to talk about Royal Caribbean's AI and computer vision program, kind of at a broader level. And then David is going to tell us a little bit specifically about what Royal is doing in that space. So Matt, if you'd come up.
So I never imagined that I would be working in the cruise industry. In fact, until a few weeks ago, I'd never even been on a cruise in my life and really knew very little about the cruise industry. I've spent most of my career, measured in decades now, working in kind of hardcore enterprise and industrial AI or machine learning or business analytics. We've called it different things over different time periods, but it's all the same kind of stuff. And I never really gave much thought to the cruise industry as a place to really push the boundaries. But recently, as I got exposed to the cruise industry, the scales fell off my eyes. And I saw what the cruise industry was. So the cruise industry really is an ideal crucible, in my mind, for innovation in enterprise and industrial AI. If you think about what a cruise company is, It's a set of semi-autonomous, vessels holding about 8,000 people at a time, for example. There's different size ranges. And it's basically an independent city on the sea, doing all the functions that happen in a city. And those are coupled to various degrees to an onshore operation, which does all the normal functions of a business, but in slightly more complicated ways. The product is a very perishable product, meaning when the ship sails, you can't sell it anymore. So revenue management is complicated. There's all kinds of other functions on board the ship as well. And we're capturing data, lots and lots and lots of data about almost everything that's happening on the ship, or at least what's happening that's public on the ship. And we're in control of all that. So it really is a crucible to do, really push the boundaries, I think, in terms of enterprise AI. And so you can see some of the functions that we have there. I mean, a cruise ship is it's a hotel and resort operation in the water. It's a retail operation. Entertainment management, comedy shows, ice capades, and water shows, and plays and whatnot. Food and beverage, obviously, full contact center operations, the call centers for all different kinds of things. Lots of social media management and monitoring and so forth. E-commerce, a lot of sales over the internet channel, a whole security and safety operation. Healthcare operations, I mean, we actually have a whole hospital on the ship because we have to be able to deal with anything that happens. Anything short of major surgery can be done on the ship. I mentioned pricing and revenue management, marketing and promotions. We're constantly doing different kinds of promotions. Enterprise and industrial IoT, right? There's distributed devices with sensors, and we're collecting that and putting signals out to the edge in all kinds of ways. Predictive maintenance and parts management. There's massive engines on the ship. There's HVAC operations. There's water purification. We're taking water in from the ocean, purifying it, and making it able for people to drink. Enormous supply chain and logistics. If you imagine that, a ship comes in to port, about 8,000 people or so are already on the ship. The guests all come off, maybe 6,500 or so. Another 6,500 come on. All the supply, all the waste that was generated comes off. All the stuff that's got to be put on the ship. All the food. Imagine how much food the 8,000 or 9,000 people are going to eat over the next 3 to 14 days. It all gets done in about 8 hours. And so it's an amazingly efficient operation. And then things like just ship deployment. Where do we put the ships? What itineraries will be most attractive? And how do we design the next generation of ships, taking everything we've learned to make better and better ships? Because at the end of the day, that's the product that we sell, the time on the ship. So I want to make a few assertions here to tell you just a little bit about at least how I see the challenges and in the cruise industry, but even more importantly, really in enterprise and industrial AI generally. All right, so the 4 assertions that I'll make, one is that algorithmically speaking, computer vision is actually a mature area. And I used to do computer vision in the 1980s actually when I was in graduate school, and it wasn't mature then. It was all manual feature engineering, coding of trying to get the patterns from the features you have. The results you would get would vary dramatically depending who was doing it. But it's pretty mature now. I think most people would agree. But the flip side of that is computer vision application to business problems, right? To business AI is very immature. So in other words, computer vision is mature, so you can understand what's there, how many people are there, who's there, what they're doing. But what do you do with that information to move some kind of business KPI that matters? How do you make a better guest experience in the case of a cruise industry? How do you have that hit the bottom line and so forth? Thirdly, so even broader than the second point, business AI in general is immature. And I'll say what I mean by that in just a second. But I think that's a statement. And that leads to the fourth thing, which is why I've been so excited about this area for many years. Business AI, industrial AI are very immature, and that means there's a lot of opportunity if we can figure out how to move them up the maturity curve. So what is mature AI? What do we mean when we say mature AI? I think what you kind of mean is that, and it's kind of a tiny font up there in the top, but it's that the data the data capture and governance is designed for AI. Okay? Data was gathered, purpose generated for AI. So you look at something like image recognition. We've got massive databases of well-labeled images, all in the same format. You can keep growing that over time. You just kind of keep turning the crank on that. Machine translations. You have massive sets of documents translated by the best human translators out there, UN documents, web pages, books, all that kind of stuff, and you can really feed that in. That's the data that people would need to apply AI to these problems, and we have the right algorithms that we know work in these kinds of cases. So the characteristics, if you look at them, 1 through 4 there, the technical problems are very well defined with clear success measures. You want to count the people in the room. You want to identify what one of these 100 animals is in this picture, and so on. Pretty large investment levels. The business value for these things is already kind of accepted. So the investment levels are steady. No one's saying like, well, do we really need AI to do this? That's well accepted. Number three, very importantly, there's large global research communities in these areas. So you're not working alone. You're working in a global community, able to leverage all the stuff that other people are doing. Universities are doing a lot of stuff, making it all public. So you've got a real big community trying to crack these problems. And what this means, so the real important part, number four there, is that the performance gains that you tend to see are driven by three main things. One is just getting more and more of the same data, right? So turning the crank on the data. Get label data, put it in, it just gets better and better. Number two is just kind of riding the wave of Moore's law and its equivalents in the modern age. Just ride the wave of more computing power. That lets you do deeper neural nets, it lets you process more data, more quickly retrain, and so forth. And then number three, just kind of tweaking the algorithms. You're using the same basic kind of algorithms, but you're just tweaking some of the key characteristics of that. And that's how you make progress in mature AI. Now, what is immature AI, and what do we mean by that? So this comic is a very famous comic, and it's used to explain a dilemma or situation that occurs in a number of contexts. I think it's very apt for the case of immature AI. So if you've not seen it before, this person is down on the ground, he's presumably drunk, and he's looking for a quarter that he dropped. And the policeman comes by and says, is this where you dropped it? And he says, no, I dropped it a few blocks down the street. And he says, so why are you looking for it here? And he said, well, the light is better here. Right? And that's something that people laugh at, but it's what I would argue we do in enterprise and industrial AI often, right? Because the data that we're using typically was captured not for AI, not to solve the enterprise or enterprise AI problems. It was captured for financial reporting, that they have to capture it, for various business reporting, different kind of BI reports people needed, or some kind of compliance. Right? That's why it was captured. So we're basically just, in the AI world, we're making do with whatever data just happened to be there. In other words, we're working where the light is best, not where we think we can find the best value. And so the characteristics of this, 1 through 4, kind of in parallel to the mature case, number one, the technical problems are not clearly linked to business problems. Right? So for example, in a customer targeting and value optimization case, you might say, well, I want to use AI to determine the optimal promotion to deliver to my customers to get the best uplift. Right? Now, you may say that's what you want to do. There may not be enough signal in the data to do that. It may literally be impossible given the data you have. Now, that's not the case in image recognition, right? If you want to say, is that a dog or a cat, there's enough signal in the data because you as a human can tell if it's a dog or a cat. So you can train an algorithm to do that eventually. Here, there may not be enough signal in the data. So you may have to say, well, I don't think we can measure the uplift. We don't have good enough data. Maybe we should just determine what the best time window to do a promotion is. Maybe there's enough data to say that. So you have to keep iterating on what the problem is. That lack of an upfront linkage between the technical and business problems is one of the characteristics. Number two, investment is tentative and small. So typically when we do these things, we're going into a business where the business function is already being done in some other way, right? People are already pricing, they're already doing promotions, they're already managing maintenance of equipment. And you come in as a foreigner into this and they say, well, is this really going to work? Okay, I'll fund a pilot, this much money, let's see if it works. So you've got to kind of prove your value every step of the way. There's no presumption that AI is relevant to the function that you're doing typically. And even if there is, you really have to justify the investment levels. Number three, in contrast again to the mature areas, the research communities are fragmented and thin. You're pretty much on your own. In some areas, like, there's one global conference a year with 50 people at it and, a pretty small event. But in general, you're on your own with this. You have to kind of figure it out by yourself. So number four, this is the key thing. What drives value in these kind of problems? What lets you get over this? Because again, this is the challenge here is that the systems here, the enterprise systems, tend to be more complicated than the cases which are currently mature. You're usually dealing with a system where people are involved, making decisions, having various reactions. There's a complex social system. There's a bunch of externalities to it. It's a more complicated system, more degrees of freedom. So it's fundamentally harder to solve. So what moves the needle is better problem formulation and setup. So deciding what to model. Are you going to model when to do a promotion or what the uplift will be? Are you going to model with equipment when something's going to fail? Or maybe you're just going to model statistically what parts in the whole portfolio are likely to fail at some point so you can stock parts better. That kind of problem formulation and setup really moves the needle in terms of performance here. Number two, let me skip to the third one there, effective use of domain knowledge. I mentioned before, you have many more degrees of freedom in these cases with not great data. So the only way to get a good solution there is to further constrain the solution using domain knowledge. So for example, that might involve If it's an engineering, like an industrial case, using engineering or physics equations. If it's marketing, it might be using just mathematically expressing the current domain knowledge and understanding and intuition of your marketing experts. But you have to use domain knowledge in some way to constrain the solution. That lets you get good results. And the last thing there, the data collection. So looking at data collection and data curation and data governance, not as a normal function, but really as a strategic imperative in two ways. One is, doing what you can to get better data, to make sure you're keeping it, to improve it, improve the quality and so forth. That's the way you get through the first hump. But ultimately, to re-instrument your whole business so you actually do start doing what's being done in the mature cases where you're gathering the data that's needed for AI. And just to give finally an example of where this was done well, self-driving cars. Right? This is a case where I think people would say it's been very successful. The progress that's happened in recent time has been very impressive. And let's say what they didn't do, right? What they didn't do to make a self-driving car was they didn't say, there's already hundreds or thousands of sensors on the car, right? Just use those and build the models to make it drive by itself. Okay, that's a very common thing you'll see in many cases in businesses and industrial operations. They essentially say that. If they'd done that, this would still be in the research labs, right? So instead what they did was they said, they got the AI scientists involved and they said, what if you had to build a model that would let a car drive by itself, what data would you need? And they come up with crazy things like, well, I'd like LiDAR, I'd like a laser that's spinning around and mapping out all these 3D images, I'd like different kinds of radar, I'd like ultrasound, I'd like all these things. And once I have all those sensors and instrumentation, I also want you to drive the car maybe a few billion miles or so, right? So I get a lot of data. And then maybe even a lot more in a simulator, because I know we have good simulators. That's what I want. So they didn't say, you're crazy. They said, let's do it. They've done that, and they built great models that let these cars drive really well. So that's how you get to the next level of making an immature business, like a lot of what we're doing in business AI and industrial AI, bring it to the next level is re-instrumenting the business. That means physically, in the physical systems we have, in our case it's our ships, putting new sensors on, and we're doing that with Levatas right now. We're putting all kinds of new video sensors and different kinds of sensors on the ships, re-instrumenting the ships, and then also the equivalent of sensors or instrumentation in the enterprise is changing how and where you collect data. What do people have to write down? What do they have to record? What do they need to snap a photo of? Doing all that kind of stuff to re-instrument the business. So in closing on that, the two things are, one, we have to function where the light is because we have to get value now. It's going to take years to really re-instrument a business and a lot of financial commitment. So to get better value now, we have to really focus on problem setup and formulation, data capture as a strategic imperative, and bringing domain knowledge into the solution of the problems. That's the first thing. But for the longer range path to maturity, you have to re-instrument the entire business. And that's what we're doing at Royal Caribbean right now. And I'm super excited to see where this goes. And I'd like to introduce David Milone now, and he's the product manager for the venue analytics program that we're doing at the Royal Caribbean.
Thank you, Matt.
With Levatas.
So as Matt just mentioned, we have to go where the light is. So where's the light? Where do we start? So one of the first things we did is we began seeing, what do we want to know? As we mentioned, ships are huge. How many people have been on a cruise? Show of hands. They're mini cities, right? The ship you're looking at right now, the Spectrum of the Sea, is one of our newest ships. It's currently sailing in China, and it can fit over 6,000 people and 2,500 crew. So a lot of people here. So the first thing we said is, what can we learn about the ship? What are some of the areas we could talk about? So this is the promenade. For those familiar with a lot of cruise ships, it's kind of the open area where you first kind of arrive on the ship. So the promenade has a lot of retail space, a lot of food space. So the first thing we did is we said, okay, so let's look at the promenade and see if we could tell how many people are there. I know the first thing you're thinking is, well, there's point of sale data. Well, what if you don't buy something? What if you're wandering? What if you're walking? So the first thing for us is, can we count people? So we took YOLO, came off the shelf, took some CCTV footage, and we said, yep, we can count people. Now what? So we immediately began looking at where we could get the biggest bang for our buck, right, in terms of guest experience. So what you're looking at here is the Windjammer. The Windjammer is on most of the Royal Caribbean ships, and it is a buffet-style marketplace. It's part of every package, so everyone that boards the ship can go to the Windjammer. The really interesting thing about the Windjammer is that on port days, it's usually the last place a person hits before they leave the ship, right? They're wrapping up, they want to go grab breakfast before they leave the ship. Alternately, on port days, it's the first place you hit the ship. So when you're arriving, you're there. I mentioned that the Allure of the Seas fits 6,000 people. That means while we have 6,000 people leaving the ship, they're hitting the Windjammer for breakfast. At the same time, the 6,000 people boarding the ship are trying to hit the Windjammer for breakfast. So understanding how populated the Windjammer is became a very important business case for us. We don't want guests, for their first experience on the ship, to be waiting in line. right? It's the last thing you want to do. So understanding how many people are on the ship was really important for us. Now, as you look at this, the first thing you think is, that's a fisheye camera. Well, YOLO doesn't really work well with fisheye cameras for those who've experienced it. So we kind of started off the gates with one of our hard use cases, unfortunately. But we knew it brought business value, right? Again, we're going where the light was. We knew where people needed information. So we immediately began annotating these images, right? Understanding how many people. So tens of thousands of images went through annotation, identifying people. As you can imagine, they had to be differentiated, right? We needed images with high density, a lot of foot traffic. We needed images with not a lot of people. As you see on the edges here, you see people start to disappear in the light. So we needed to make sure that we captured the right amount of people. We needed to train the algorithm to understand, is that a person? Right? So you look at some of these areas, it was really important that we understood that. As you look in the center, what you'll see is because of the way of the fisheye, one person could take up a lot of real estate. So now we're training the model. We need to make sure that we have enough people in those areas to actually train. Otherwise, you're going to have kind of these dead zones. So for us, it was really important to understand and make sure that we're getting the annotation right. So again, about 10,000 images went through. The second thing is, okay, now how do you train? How do you do the inference? Where's that happening? I'm sure that most of you are thinking, let's do it in the cloud. We're on a ship out to sea. The allure of the seas right now is somewhere between St. Martin and San Juan. So probably not a real good internet connection out there on the sea. And whatever bandwidth we do have is guest-facing. Right? We want to make sure the guests are able to experience our app and other things. So then we said, okay, how do we solve that? And we actually have some help from our friends at Lambda Labs here today. So what we did is we went and got rigs, right? We got servers installed on several of our ships. So we have 3 ships now that have an 8 GPU, right, Lambda Blade server on them. So that we could do all of that information, all that number crunching on ship. So it's not an easy thing, right? But now we've been able to set ourselves up for success. So now we start to create that loop of information feedback. So now, as we mentioned, an important part to that is if we train on the Windjammer marketplace, right, this buffet that we see a lot of people, the Windjammer can fit over 1,000 people at any given moment. There's a Windjammer on every ship. So now how do we begin taking that same model and applying it to other ships? So of course, we get a lot of transfer learning that happens with that. But it's important to keep an eye on the drift that could occur. Because as you see here, on this particular Windjammer, a lot of booths. On the Windjammer on the Harmony of the Seas, which is operating out of Orlando, Florida, that one has a lot more stool action, right? Everyone's at high tops. So although the model knows how to identify people pretty well here, when you get into that small drift, what have you taught the model? Have you taught the model that booths are somehow integral to people? So now you need to be able to take your model and make those small adjustments. So it's important that the pipeline was set up to do that. The other thing we noticed right away in our training is that high density images is where our accuracy wobbles a little bit. So when you look at an image like this, anything under 80 people in a frame, we're at about 90% accuracy and being able to tell that. Once you get above 80, you start pushing into 120 people in a frame, it begins to lower our accuracy a bit. Now, the important part, as Matt mentioned, though, is where can we drive business value? Is there a real business value difference between 100 people and 115 people in a single image? No, it's busy, right? That's what's important. So understanding how to leverage that right away and begin to get business value so that we can think longer term on how we want to do things was really important for us. So what this allowed us to do then is start training on higher density images. To say, let's start pushing that. But at the same time, we started reevaluating how we're doing things. In this particular image, you're looking at the Windjammer. The Windjammer Marketplace Buffet is covered by 9 cameras, kind of like in a U shape, right, a horseshoe. So we can give you pretty good analytics within that horseshoe, right? We can give you heat mapping of where people sit. We can start to get into seat spoilage, right? It's a very important option. If you've got 4 seats and 3 people take it up, that 4th seat's kind of dead. It's ruined for other guests, right? They don't want to kind of sit away from the group. So we can get all those analytics in one venue. The trick is thinking of guest impact. If I tell you the Windjammer's busy, and I say, hey, Windjammer Marketplace is busy, your next question is going to be, great, where do I go? So it's important that we need to be able to quickly get to other venues. So one of the things that we began investigating is instead of covering a whole area, can't we just cover the exits and entrances? And now count people as they enter and exit a venue. You don't need as big a camera coverage. You'll be able to train faster. You'll be able to repeat the model quicker. So now we start to think, okay, now I can tell you a lot about the Windjammer, but I can also tell you a little bit about all of the other locations. So this is an example for those that have been on a Royal Caribbean ship. This is actually on the ship. I know it looks very nice, very outdoors, right? This is actually in the Central Park area. So it's an entire area kind of designed like an outdoor seating area. There's places to eat, there's places for retail. So being able to capture this area and being able to say, I can tell you how many people are in each venue. I can tell you how many people are waiting to get into each venue. Now we can start to direct the guests where they should go, right? If you're looking for steak, I'm going to send you over here, and I'm going to send you to Park Cafe. If you're looking for a quick meal, oh, it's going to send you to Windjammer. Windjammer looks busy. Let's send you to Johnny Rockets instead. Having that ability to impact the guest directly in the short term, but then also feeding that data to our strategy teams who make the decisions on how big a venue is. Does the Windjammer need to be bigger? Instead of saying, hey, the Windjammer is always busy, let's make sure we divert the guest. That's directly guest impacting, but for the future. And we talk about, as we start to move forward, what other metrics would we need? What other data could we use? So as we begin to look at venues like this, we start to think of, okay, let's get line counting. Let's install cameras. Let's get better views of things. And so when you look at something like this is the next beast we're tackling. This is main dining room. It's 3 floors, and it each fits about 1,000 people per floor. So if you said, I want to cover the whole area, that's a lot of cameras. That's a lot of inferencing. That's a lot of training. But can I tell you how many people on each floor? So this is where we begin to start looking at how we can drive guest benefit right away while preparing for those future metrics and preparing our ships. So when the Allure of the Seas goes into dry dock next year for all of its upgrades, we can say, we know what are the other areas we need. We know where we need to shine the light next. So we can begin making those changes in advance. And with that, I'll hand back off to Daniel.
All right, thank you guys. So I'm going to open it up for questions here in a minute. Hopefully it's exciting and interesting to hear more about what Royal Caribbean is doing. We're going to open it up here for questions in just a minute. Before we do that, I just wanted to mention as Levatas, through our experience working on projects like this, working with partners like Royal Caribbean, we've run into a lot of these types of challenges. We've built a platform to help solve a lot of these challenges called Recon. We have a booth out in the Expo Center. I'm not going to talk a lot about it here today, but I'll just tell you the platform is built to facilitate end-to-end computer vision automation. It's built to support custom workflows, and then also to facilitate human-in-the-loop automation. So in cases where you need that tight collaboration between AI models and humans, our platform is built for that. If you have more questions, if you don't get a chance to ask here in the rest of this session, or if you have questions about Recon, swing by our booth. We'd love to talk. All right, questions?
Thanks. Question for Matt. In the kind of debate between build, buy, outsource, and so on, do you guys at Royal Caribbean also do any computer vision in-house as well, or?
Yeah, so we're working with Levatas on that. We have many computer vision experts as well, but the key thing to your point is we spend a lot of time making sure, because good talent is so scarce. We want to make sure that where we're investing and doing our things ourselves are areas where new innovation is needed. If there's any case where we can either buy something ready to go or can partner with experts like Levatas, and that we'll do that. So I don't want to build anything we don't need to build, and where we do need to build, I want to invest very heavily.
Time for one more.
As someone who's done some computer vision training myself, that fisheye lens scenario looked like an absolute nightmare. I'm wondering, why wasn't your first instinct to say, we need a different camera angle?
Yeah, I'll cover that. We lost a lot of sleep over that one. So this is where the business dictated the need, right? So they said, this is the area to do that. When you change cameras out on ship, you have to make sure they're marine grade. You have to do it usually during dry dock. So for us, we really said, well, we can wait 6 months to do this and get all the conditions right, or we can start doing what we can now.
And just to clarify, when he said dry dock,
yeah,
the ships are so expensive, right? Every hour they're not in service costs a lot of money. So periodically we put it in dry dock for an extended period of time to do all kind of upgrades. And that happens rarely. That's when you'd have to do it.
And so the good news for us now, although we've lost a lot of hair pulling out over the last 6 months to a year on doing this, we kind of took, from a model perspective, the hardest case. So when we talk about using a directional camera at an entrance, it's like, give us a week, no problem. Yeah, so lost a lot of sleep over it, but we took the hardest case first from a camera perspective because the business dictated it. Yeah.
All right, thank you, Matt, Daniel, and David.
Excellent. Thank you, everybody.